Dear student, previous class we have discussed regarding the physical trends in a periodic table. Okay, there are two physical trends already we discussed. What are they? Ionization enthalpy and one more is atomic radius. Now we'll move for the third physical properties, that is electron gain enthalpy. Electron gain enthalpy. The name of these physical trends itself says the property of what? That particular term. What is that? Electron gain enthalpy. You know the term gain. Gain means what? Taken. Okay, so electron gain enthalpy. Enthalpy refers to energy. Enthalpy refers to energy. Hagadre one thing is sure, energy is required or released. Okay, here energy term should be present with the electron gain. So I'll go for the definition wise. First we'll go for the definition wise. What is the definition of electron gain enthalpy? Electron gain enthalpy we can define in terms of what? Energy. So amount of energy required or released. Here amount of energy required or released to what? Energy required or released to add electron to outermost shell or valence shell. So here amount of energy required or released. Here both terms are used. Amount of energy required or released to add electrons to the outermost orbital to neutral gaseous atom. Okay, neutral gaseous atom. So you just write outermost shell, that is enough. Okay, so here the term just see required and released. First I will take an example. X is an any element. Once you add the electron plus E, that plus E indicates electron should add it to the particular element, and whatever the ions will form, obviously when the electron is added it will produce an ion, that is X minus will produce this enthalpy of gain of enthalpy, that's it delta E H. This may be required or released, and you know the physical term, what is that? Exothermic and endothermic. Okay, exothermic and endothermic. What is the meaning of exothermic and endothermic? Exothermic means released energy, released energy. Endothermic means required energy, absorbed ಮಾಡ್ಕೊಂಡ್ರೆ what is that? Endothermic and exothermic ಅಂದ್ರೆ energy release. In terms of joule ಅಲ್ಲಿ ಹೇಳಿದ್ರೆ or energy ಅಲ್ಲಿ ಹೇಳಿದ್ರೆ, release energy should be negative. Release energy should be in the terms of negative. Required energy obviously positive. Okay, positive and negative will come. Okay, so hagadre energy required obviously positive. Required should be positive. Whatever the energy released, that should be in terms of negative. Positive and negative energy released or energy required. So this factor will obviously produce the negatively charged ion. So X minus will produce, so it may be plus or minus, positive or negative energy will absorb. Different kinds of terms will introduce here. Some of the elements, okay, most of the element or many elements will energy release their energy. Energy release means what? Negative will come. Electron gain enthalpy. electron add ಮಾಡಲಿಕ್ಕೆ ಎಷ್ಟು ಎನರ್ಜಿ ರಿಲೀಸ್ ಆಗ್ತದೆ ಅಥವಾ ರಿಕ್ವೈರ್ಡ್ ಇದೆ ಅದನ್ನ ಹೇಳುವಂತದ್ದು electron gain enthalpy. Most of the elements are energy released. For example, Cl is there. For example, Cl here 17 is the atomic number. Once you write the electronic configuration, 1s2, 2s2, 2p6, 3s2, 3p5. total number of electron estide ಈಗ 17. Just concentrate on what outermost shell only. Just concentrate on outermost shell. Here 3s2 3p5 is the outermost shell and electron ಎಲ್ಲಿ add ಮಾಡ್ತಾ ಇದೀವಿ outermost shell ಗೆ. So this is an atom. Electrons are revolve around the nucleus. Here our task is what? Electron should add it to the outermost shell. The last orbital we can add the electron. Once you add the electron, it will release or required energy. So just observe these 3s2 3p5. I already told in the outermost shell the stable electronic configuration should be 8 electrons present in a outermost shell. 8 electrons present in a outermost shell. But here how many electrons are there? Only 7 electrons present in the outermost shell. It required 1 electron. If the 1 electron is added, it becomes 8. That is 3s2 3p6 will come. So that's the most stable condition. That's why here energy released will takes place because already it required 1 electron. So now electron add ಮಾಡಿದ್ರೆ energy release ಆಗ್ತದೆ. So in case of what? Neon. In case of neon is atomic number 10. Neon having the atomic number 10. While writing the electronic configuration 1s2 2s2 2p6. 1s2 2s2 2p6 and you know that it is an inert gas. It is an inert gas. N10 is an inert gas. Just observe the outermost shell. How many electrons are present? 2s2 2p6, total 8 electrons are present. If the atom having 8 electrons, that is the most stable condition. That's why adding of electron is difficult. Adding of electron. Here already 8 electrons are present in these orbitals. Okay, 1 2 3 4 5 6 7 8 electrons are there. One more electron adding, ಇನ್ನೊಂದು electron add ಮಾಡಲಿಕ್ಕೆ, which is difficult in the sense what? It should require energy to add electron. Once you add electron, required electron will come, then it will become positive. But here which is an negative. ಇಲ್ಲಿ ಒಂದು electron add ಮಾಡಲಿಕ್ಕೆ ಅದೇ ಕಾಯ್ತಾ ಇದೆ, but ಇಲ್ಲಿ already 8 electrons are there. So one electron adding is difficult, but here one electron adding is easy. Okay, so here positive, here negative. Now it is an exothermic reaction and it is an endothermic reaction. Exothermic and endothermic reaction. But in a ionization enthalpy which is easy. Okay, ಅಲ್ಲಿ ಒಂದು ಟ್ರೆಂಡ್ಸ್ ಕಂಟಿನ್ಯೂಟಿ ಇರ್ತದೆ. But here there is no continuity in their what properties or enthalpy ಹೇಗೆ ಚೇಂಜ್ ಆಗ್ತದೆ ಅದನ್ನ ಒಂದು ಸೀರೀಸ್ ಅಲ್ಲಿ ಹೇಳಲಿಕ್ಕೆ ಆಗುದಿಲ್ಲ. It should be very. We'll move for the physical trends, variation in a this what gain enthalpy, how it will be varies in a periodic table. And I will go for the across the period. Across the period how it will be varies. And you know the concept across the period. What about effective nuclear charge and atomic radius? So across the period effective nuclear charge, ENC, effective nuclear charge increases or decreases across the period in the sense what? In this direction. Just imagine the second period: boron, carbon, nitrogen, oxygen and fluorine. Boron, carbon, nitrogen, oxygen and fluorine, and one more neon. I took neon. So size of this series across the period, size of this series, boron bigger in size, then size should be decreases. Why? Because effective nuclear charge increases, size should be shrink. Okay, so this is the order, and neon having the smaller size in this. Okay, and just observe this only. Okay, I will not take on what neon. Why? Because I will tell later. Here across the period effective nuclear charge decreases, and one more, atomic radius. What about atomic radius? Or in terms of size also decreases. As the effective nuclear charge increases, size decreases. So here nucleus are present, all atoms having the nucleus. Just observe that nucleus are very close to the orbital compared with the first. Here distance is more, here distance is small. So electrostatic force ಅಥವಾ effective nuclear charge ಜಾಸ್ತಿ ಇದೆ ಅಂತ ಹೇಳಿದ್ರೆ it will attract the electron towards itself. Attractive force is more towards itself. Compare with the first. ಇದಕ್ಕೆ ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ here effective nuclear charge ಜಾಸ್ತಿ ಇದೆ, pulling of electron is high. That's why adding of electron easy to here. Already there is a force exists. effective nuclear charge ಜಾಸ್ತಿ ಇದೆ. ಹಾಗಾದ್ರೆ in general we can say across the period delta Eg, that is nothing but what is that, electron gain enthalpies, that should be increases across the period. Electron gain enthalpy increases, but down the group. So I hope you understood. What about across the period? ಏನಾಗ್ತದೆ, you just remember what is the delta H EHG is increases, the electron gain enthalpy increases across the period, size is decreases, effective nuclear charge increases. Okay, now we'll move for the next term, important term, that is down the group. So what about down the group? In the down the group, just take example hydrogen, lithium, sodium, potassium. Down the group, size increases. Here center having nucleus, between the distance between the nucleus to outermost shell goes on increases, in the sense what, effective nuclear charge decreases, and the size increases. So here adding of electron bit difficult, ಯಾವುದೇ ಫೋರ್ಸ್ ಇಲ್ಲ ಅಲ್ಲಿ, ಎನರ್ಜಿ ರಿಲೀಸ್ ಆಗುದಿಲ್ಲ. Okay, energy does not release, energy release ಆಗ್ತಾ ಇಲ್ಲ, but here energy required because there is no force of attraction or effective nuclear charge ಕಡಿಮೆ ಇದೆ, ಹಾಗಾಗಿ ನಾವೇ ಎನರ್ಜಿನ ಸಪ್ಲೈ ಮಾಡಬೇಕು. ಸೊ ಹಾಗಾದ್ರೆ down the group, what about the electron gain enthalpy? That should be decreases. Down the group should be decreases in electron gain enthalpy. Electron gain enthalpy decreases, or we can say more positive or less negative. Okay, usually electron gain enthalpy we can say in terms of more negative and more positive. Okay, or less negative. So across the period ಏನಾಗ್ತದೆ, more negative, down the group less negative. That's it, same thing. Or you can write the decreases in a down the group and across the period increases. Okay, I hope you understood. And ಇದನ್ನ ಹಾಗೆ ಇಟ್ಟಿದ್ದೀನಿ neon. Why? Because I already told neon already having 8 electrons, adding of electron is difficult. That's why this inert gas or 18th group elements are having positive electron gain enthalpy. All 18th group elements are having positive electron gain enthalpy, but 17th group having more electron gain enthalpy, so negative electron gain enthalpy, negative and positive. I hope you understood this concept. Now I'll take for the exception case. Okay, so according to periodic table ಏನಾಗಬೇಕಿತ್ತು, here just see it is in periodic table. Across the period more electronegative, down the group less electronegative, ಅಥವಾ increases across the period, decreases down the group. So according to them, oxygen and fluorine, okay, oxygen and fluorine second period ಅಲ್ಲಿ ಬರುವಂತ elements, these should be having the highest electron gain enthalpy, but that is not possible fluorine ಗಿಂತ chlorine. Okay, so here sulfur, chlorine, so this is order. Okay, ಇದು second period ಅಲ್ಲಿ ಬಂದ್ರೆ this should be in a third period, second period and third period. Sulfur, oxygen below ಬರೋದು sulfur, fluorine ಕೆಳಗೆ ಬರುವಂತದ್ದು oxygen. So according to the law, here increases, here decreases. So ಈ ಆರ್ಡರ್ ಅಲ್ಲಿ ಬಂದ್ರೆ fluorine ಗೆ highest electron gain enthalpy ಬರಬೇಕಿತ್ತು, down the group less ಆಗಬೇಕಿತ್ತು, but there is a change in this. Okay, ಇದಕ್ಕೂ ಮತ್ತೆ ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ change ಇದೆ. According to the law or according to the what concept wise ಬಂದ್ರೆ fluorine having the highest electron gain enthalpy, but which is not possible. Why? Because now I'll take only these two, because rightmost ಬರುವಂತದ್ದು ಇದೆರಡು ಮಾತ್ರ. ಇದು ನೆಕ್ಸ್ಟ್ ಬರೋದು inert gas ಗೆ ಪಾಸಿಟಿವ್ ಬರ್ತದೆ, ಇದು ನೆಗೆಟಿವ್ electron gain enthalpy ಬರುವಂತದ್ದು. Now I'll take the what orbital diagrams. So fluorine F should be 9. I'll write the diagram wise 1s2 2s2 2p5, 1s2 2s2 2p5. Chlorine 17, here 1s2 2s2 2p6 3s2 3p5. See here how many electrons are present in outermost shell. You should remember. Okay, 1s2 2s2 2p5 here for fluorine. So here 1s2 2s2 2p6 3s2 3p5. Okay, so outermost shell both are having the same atomic number, sorry, same number of electrons. There are 7 electrons are there. 1 2 3 4 5 6 7. Okay, there are 7 electrons. Here also 1 2 3 4 5 6 7. Both are having 7 electron only because both are belongs to same group ಅಲ್ಲಿ ಬರ್ತದೆ, ಹಾಗಾಗಿ 7 electron ಇದೆ. And just observe this, ನಮ್ಮ intention ಏನು, we should add 1 electron to this orbital. Here also add 1 electron to this orbitals. ಹಾಗಾದ್ರೆ just observe this, already 7 electrons are there. What is the distance between these two? X. We can take x. Okay, I will take x. Here also this distance we should take x2. Just imagine which distance is longer. Obviously x2 having larger gap than the x1. Okay, and you know the basic concept what like poles are repel each other, unlike poles are attract each other. Here our intention, we are going to add 1 electron to here. Already electrons are there. There should be a repulsion between these electrons because minimum distance present. But here if you add electron, this having the sufficient space to add an electron. That's why compare the fluorine and chlorine. Compare the fluorine and chlorine. Chlorine having Cl having more electron gain enthalpy than the fluorine. Okay, so if fluorine delta EgHF, delta EgHF is X, that should be minus only because 17 group element. Okay, so delta EgHCl, that we can take minus x2, here x1 minus x2. According to this concept, here repulsion of electron is more, here repulsion of electron is less because we are bigger in size. ಜಾಸ್ತಿ ದೂರ ಇದ್ದಾಗೆ ಬೇರೆ ಬೇರೆ ಪ್ಲೇಸ್ ಅಲ್ಲಿ ಪ್ಲೇಸ್ ಮಾಡಬಹುದು ಯಾವುದನ್ನ, ಎಲೆಕ್ಟ್ರಾನ್. ಇನ್ ಕೇಸ್ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಆಡ್ ಮಾಡಬೇಕಂತ ಹೇಳಿದ್ರೆ sufficient space is required. So minus x2 obviously more negative than the minus x1. So ಹಾಗಾದ್ರೆ they may ask for one more question. What is that? Which element having the more electro gain enthalpy? You should write chlorine only. You should write chlorine only, not fluorine. Okay, according to that what concept variation, fluorine ಜಾಸ್ತಿ ಬರಬೇಕಿತ್ತು, but this concept will leads to form what Cl having the more electron gain enthalpy. This regarding the electron gain enthalpy. One more term is present that we'll discuss now. Last physical trends in the what periodic table, that is electronegativity. Okay, so here electronegativity and electron gain enthalpy, don't confuse with that because both are different, but similarity ಸ್ವಲ್ಪ ಇದೆ. Okay, there is a bit similarity between these electronegativity and electron gain enthalpy. Okay, here electronegativity, first I will go for the definition. What is the definition of an electronegativity? And one thing you should remember, ಇಲ್ಲಿ ತನಕ ಡಿಸ್ಕಸ್ ಮಾಡಿರುವಂತದ್ದು particular ಒಂದು ಎಲಿಮೆಂಟ್ ಗೆ ಮಾತ್ರ, but this electronegativity which is used for the molecular level, that means what, one atom should bonded with the another atom. For example, HCl. Okay, HCl, okay, or NaCl. These are all the molecular levels. So ಇಲ್ಲಿ electronegativity ನ ಹೇಳಬೇಕಾದ್ರೆ that should be corresponding with the another atom. ಇನ್ನೊಂದು atom ಗೆ correspondence ಆಗಿ ಹೇಳುವಂತದ್ದು. What is the meaning of, or what is the definition for the electronegativity? So we can define electronegativity, which is very important for one more question. Define electronegativity. So we can define electronegativity as it's an capacity of an atom. It's a capacity or ability of an atom, okay, of an atom to attract shared pair of electron towards itself. Okay, so here this is the exact definition. Okay, so what is that? Capacity of an element or ability of an atom to attract the shared pair of electron towards itself ಅಂತ ಹೇಳಿದ್ರೆ, so one atom is present, shared pair of electron is nothing but what? Bonded electrons. Okay, bonded electron. For example, I will take HX. Hydrogen is bonded with the X should be any element. Okay, so here these bonds are represent what? Two electrons. ಒಂದು bond ಅಂತ ಹೇಳಿದ್ರೆ ಎರಡು electron. Here this atom having the capacity to attract towards itself ಯಾವುದು? shared pair of electron. ಇಲ್ಲಿರುವಂತ ಎರಡು electron will attract it towards X. that is the capacity of this particular atom. ಒಂದು atom ಗೆ ಡೈರೆಕ್ಟ್ ಆಗಿ ಹೇಳಲಿಕ್ಕೆ ಆಗುದಿಲ್ಲ. but electron gain enthalpy, ionization enthalpy, there should be a particular, but ಇದಕ್ಕೆ particular quantity ಇಲ್ಲ. it should be varies with the different elements. once it having HX particular electronegativity values, okay, that should be 4 like that. ಏನೇ ಇರಬಹುದು. okay, and if it is react the same X bonded with some other molecule like Na, so this will having the different electronegativity. hagadre one thing is sure, what is that? which is not fixed, but electron gain enthalpy, ionization enthalpy, there should be a fixed values, that having the fixed values. so electron negativity, there should be varies, and it should be present only in a bonded atom. okay, ಎಲ್ಲಿ ಬಾಂಡ್ ಆಗಿರ್ತದೆ ಅದರಲ್ಲಿ ಮಾತ್ರ ಇರುವಂತದ್ದು, that is an what? electronegativity. here also how the electronegativity is varies across the period as well as down the group. ಏನಾಗ್ತದೆ ಅಂತ across the period. so once the electron having the capacity to attract towards itself, ಯಾವಾಗೆಲ್ಲ ಬರ್ತದೆ? so ಇಲ್ಲಿ ಒಂದು ಐರನ್ ಪೀಸ್ ಇದೆ. okay, ಇದನ್ನ ನಾವು ಇನ್ನೊಂದು ಅಟ್ರಾಕ್ಟ್ ಮಾಡಬೇಕಿದೆ, ಇನ್ನೊಂದು ಐರನ್ ಪೀಸ್ ಇಟ್ಟರೆ ಆಗ್ತದಾ? no, you should place the magnet. okay, ಒಂದು ಮ್ಯಾಗ್ನೆಟ್ ನ ಹತ್ರ ತಗೊಂಬಂದಾಗೆ this should be attracted towards itself. same concept here also. electronegativity means what? here attraction of what? electron towards X should be any element. okay, towards X. ಹಾಗಾದ್ರೆ ಇಲ್ಲಿ ಏನಾಗಿರಬೇಕು? more effective nuclear charge should be present. ಹಾಗಾದ್ರೆ X should having the more effective nuclear charge or lesser in size also. so magnet ನ ನೀವು ಹತ್ತು ತಗೊಂಡು ಬಂದರೂ ಆಗ್ತದೆ, ಅಥವಾ ಇಲ್ಲಿ magnet ನ ಏನು ಕೆಪಾಸಿಟಿ ಜಾಸ್ತಿ ಮಾಡಿದ್ರು ಆಗ್ತದೆ, ಇಲ್ಲ these iron piece should come closer also will attract. okay, same concept apply here also. across the period ಏನೆಲ್ಲ ಆಗ್ತದೆ ಅಂತ ನಿಮಗೆ ಗೊತ್ತಿದೆ. what happens in the across the period? effective nuclear charge increases, is it right? size will decreases. so we apply both the concept here. so ಇಲ್ಲಿ ಏನು ಮಾಡಿದೀವಿ? ಮ್ಯಾಗ್ನೆಟಿನ ಸ್ಟ್ರೆಂತ್ ಜಾಸ್ತಿ ಮಾಡಿದ್ವಿ, ಅದ್ರ ಜೊತೆಗೆ ಎಲೆಕ್ಟ್ರಾನ್ ಹತ್ರ ತಗೊಂಡು ಬರ್ತಾ ಇದ್ದೀವಿ. so here also across the period electronegativity increases. why? because the same rule or same concept we should apply. effective nuclear charge increases, size decreases, there should be a more effective more electronegativity values, and these electronegativity values given by the Paulings gives the electronegativity value, and according to him this electronegativity values varies from 0 to 4 only. okay, ಅದೊಂದು particular scale. okay, ಹೇಳುವಂಥದ್ದು this will depends on particular atom. ಯಾವ್ದ್ರ ಜೊತೆ ಬಾಂಡ್ ಆಗಿದೆ ಅದರ ಮೇಲೆ ಈ ವ್ಯಾಲ್ಯೂ ಡಿಪೆಂಡ್ ಆಗಿ ಇರ್ತದೆ. ಇನ್ ಕೇಸ್ more electropositive ಜೊತೆ ಬಾಂಡ್ ಆಗಿದ್ರೆ they are having the more electronegative atom, more electronegative. one thing is remember here, electronegativity across the period there should be increases. what is the reason here? reason should be effective nuclear charge increases, size decreases. same rule you should apply. then next, down the group. what happens in the down the group? size ಏನಾಗ್ತದೆ? effective nuclear charge decreases, is it right? effective nuclear charge decreases and size increases. ಎರಡೂ ಕೂಡ ಅಗೇನ್ಸ್ಟ್ ಇದೆ. ಇಲ್ಲಿ ಮ್ಯಾಗ್ನೆಟ್ ನ ಕ್ವಾಂಟಿಟಿನ ಕಡಿಮೆ ಮಾಡ್ತಿದ್ದ, ಕೆಪಾಸಿಟಿನ ಕಡಿಮೆ ಮಾಡ್ತಿದ್ದೀವಿ, ಇನ್ನೊಂದು ಎಲೆಕ್ಟ್ರಾನ್ ನ ದೂರ ತಗೊಂಡು ಹೋಗ್ತಾ ಇದ್ದೀವಿ. ಹಾಗಾದ್ರೆ pulling nature will reduces. so across the period electronegativity electronegativity decreases down the group. Across the period increases, down the group decreases. So this is about what? Electronegativity. And which element having the more electronegative ಇಲ್ಲಿ ಎಲ್ಲ ಫ್ಯಾಕ್ಟ್ ಆಗೋದು ಯಾವುದಕ್ಕೆ? ಅಕ್ರಾಸ್ ದಿ ಪೀರಿಯಡ್. ಜಸ್ಟ್ ಇಮ್ಯಾಜಿನ್ ದಿ ಪೀರಿಯಾಡಿಕ್ ಟೇಬಲ್ನ ಕನ್ಸಿಡರ್ ಮಾಡಿ. ಸೊ ಅಕ್ರಾಸ್ ದಿ ಪೀರಿಯಡ್ ಡೌನ್ ದಿ ಗ್ರೂಪ್. ಓಕೆ, ಅಕ್ರಾಸ್ ದಿ ಪೀರಿಯಡ್ ಏನಾಗ್ತಾ ಇದೆ? ಇನ್ಕ್ರೀಸಸ್. ಡೌನ್ ದಿ ಗ್ರೂಪ್ ಡಿಕ್ರೀಸಸ್. ದಟ್ ಮೀನ್ಸ್ ವಾಟ್? leftmost rightmost element should having the more electronegative. Is it right? More electronegative. And you can't consider the 18th group element because already filled. ಅದಕ್ಕೆ ಯಾವುದೇ molecular level ಅಲ್ಲಿ ಇರುವುದಿಲ್ಲ. Almost it should be present at NE AR like that, which is not belongs to HNE. ಈ ತರ ಎಲ್ಲ ಬರುವುದಿಲ್ಲ. ಓಕೆ, ಸೊ ಎಲೆಕ್ಟ್ರೋನೆಗೆಟಿವಿಟಿ ಹೇಳಬೇಕಾದ್ರೆ ಅದು ಬಾಂಡ್ ಆಗಿ ಇರಬೇಕು. ಶುಡ್ ಬಿ ಬಾಂಡೆಡ್ ವಿತ್ ಈಚ್ ಅದರ್. ಅದು ಬಾಂಡ್ ಆಗಿದ್ರೆ ಮಾತ್ರ ವಿ ಕ್ಯಾನ್ ಸೇ ದ ಎಲೆಕ್ಟ್ರೋನೆಗೆಟಿವಿಟಿ. ಹಾಗಾದ್ರೆ ಸೊ ಲೆಫ್ಟ್ ಮೋಸ್ಟ್ ರೈಟ್ ಮೋಸ್ಟ್ ಅಲ್ಲಿ ಬರುವಂತದ್ದು 18th ಗ್ರೂಪ್ ಬಿಟ್ಟು ಅಂತ ಹೇಳಿದ್ರೆ 17th ಗ್ರೂಪ್. ಇನ್ನು 17th ಗ್ರೂಪ್ ವಿಚ್ ಇಸ್ ದ ಫಸ್ಟ್ ಎಲಿಮೆಂಟ್? ಫ್ಲೋರಿನ್ is the first element. So electronegativity is highest for the fluorine. Electronegativity value highest for the fluorine. That value should be 4. That value should be 4. Least ಯಾವುದಕ್ಕೆ ಬರ್ತದೆ? ಹಾಗಾದ್ರೆ ರೈಟ್ ಮೋಸ್ಟ್ ಅಲ್ಲಿ ಬಾಟಮ್ ಅಲ್ಲಿ ಬರಬೇಕು. ಇಸ್ ಇಟ್ ರೈಟ್? ಇದು ಪೀರಿಯಾಡಿಕ್ ಟೇಬಲ್ ಆದ್ರೆ ಹೀಗೆ ಮಾಡುವಂತದ್ದು ಇನ್ಕ್ರೀಸಿಂಗ್ ಆರ್ಡರ್. ಸೊ ಇಲ್ಲಿ ಯಾವ ಎಲಿಮೆಂಟ್ ಬರ್ತದೆ? ದಟ್ ಶುಡ್ ಬಿ ಲೆಸ್ಸರ್ ಎಲೆಕ್ಟ್ರೋನೆಗೆಟಿವಿಟಿ. ಇಲ್ಲಿ ಯಾವ ಆಟಮ್ ಬರ್ತದೆ? ದಟ್ ಶುಡ್ ಬಿ ದ ಮೋರ್ ಎಲೆಕ್ಟ್ರೋನೆಗೆಟಿವಿಟಿ. ಎಕ್ಸೆಪ್ಟ್ ವಾಟ್? 18th ಗ್ರೂಪ್ ಮಾಡ್ಲಿಕ್ಕಿಲ್ಲ, ಯಾಕಂದ್ರೆ ಅಲ್ಲಿ ಆಲ್ರೆಡಿ ಫಿಲ್ಡ್ ಆಗಿದೆ. ಉಳಿದಿರುವ ಎಲಿಮೆಂಟ್ಗೆ ಮಾತ್ರ ಬೇಕಾಗುತ್ತೆ. ದಿಸ್ ರಿಗಾರ್ಡಿಂಗ್ ದಿ electronegativity and physical trends in a periodic table. Okay, dear student, now we'll recall entire physical trends in a single chart. Okay, this is very important. ನೀವು ಏನೆಲ್ಲ ಕಲ್ತಿದ್ರೆ ಅದನ್ನೆಲ್ಲ ಒಂದೇ ಚಾರ್ಟ್ ಅಲ್ಲಿ ಬರೆಯುವಂತದ್ದು. This are very important. Here I am using different colors of pens to indicate the how it is varies, how it is across the period and down the group in general ಹೇಳುವಂತದ್ದು. That first thing is what? Atomic radius. You know 7 periods are there. 7 periods are there, 18 groups are there. Across the period ಏನಾಗ್ತದೆ? down the group ಏನಾಗ್ತದೆ? Just recall with yourself. Okay, just recall with yourself before I am writing the what the exact concept. Now across the period, that means red color, this arrow marks indicate increases. Okay, that arrow mark indicates increases. I'll write the above, ಅದ್ರ ಮೇಲೆ ಬರಿತೀನಿ. ಸೊ ಅಟಾಮಿಕ್ ರೇಡಿಯಸ್ ಅಕ್ರಾಸ್ ದಿ ಪೀರಿಯಡ್ ಏನಾಗ್ತದೆ? ಯು ಶುಡ್ ರಿಮೆಂಬರ್ effective nuclear charge increases, side should be decreases. So effective nuclear charge increases, atomic radius should be decreases ಆಗ್ತಾ ಇದೆ. So same thing across the period. Down the group, adding of new shells will take place. That's why atomic radius increases. Across the period decreases, down the group increases. Group 1 to group first group ಅಥವಾ ಯಾವುದೇ ಗ್ರೂಪ್ ನ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ atomic radius increases down the group. That is the first point. So next we'll move for ionization enthalpy. So across the period, first we'll take across the period what happens. Okay, across the period bandre effective nuclear charge increases, removal of electron is difficult. That's why so ionization enthalpy ಅಂತ ಹೇಳಿದ್ರು minimum amount of energy required to remove an electron. Energy required ಇಲ್ಲಿ ಸೈಜ್ ಕಡಿಮೆ ಇದ್ದಾಗ ಏನಾಗ್ತದೆ? ಜಾಸ್ತಿ ಎನರ್ಜಿನ ಸಪ್ಲೈ ಮಾಡಬೇಕು. ಸೊ ionization enthalpy increases. What about down the group? Okay, what about down the group? Down the group ಬಂದಾಗ ionization enthalpy down the group size should be increases, effective nuclear charge decreases, easy to remove electron. That means ionization enthalpy decreases. Okay, so down the group decreases. Next we'll move for the electron gain enthalpy. ಇಲ್ಲಿ 18th group ಅನ್ನ ಕನ್ಸಿಡರ್ ಮಾಡಲಿಕ್ಕೆ ಇಲ್ಲ, 18 because already filled. Electron gain enthalpy till 17th group ತನಕ ಮಾತ್ರ. So I'll write it in a black ink for the electron gain enthalpy. Here energy required or released. So across the period, here you should write in terms of more negative or less negative ಅಥವಾ increase or decrease. That's okay. Electron gain enthalpy size decrease ಆಗ್ತಾ ಇದೆ ಅಂತ ಹೇಳಿದ್ರೆ electron add ಮಾಡೋ ಕೆಪಾಸಿಟಿ ಕೂಡ ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋಗ್ತದೆ. So more negative, or we can say energy released will take place across the period more negative or increases. In general we can write increases. Yadu electron gain enthalpy. What about down the group? I'll write here down the group electron gain enthalpy, EGE. Electron gain enthalpy is less negative, or in terms of what? Decreases. It should be decreases. Yadu electron gain enthalpy. Ella concept kuda nimge gottirbeku. And the last point, that is electronegativity. Electronegativity usually that is based on what? Effect bonded atoms jothe idaga matra heluvanthadu. That should be in a Pauli scale. Across the period electronegativity value increases in electronegativity increases. Down the group we should write decreases. Okay, this is very important concept for what? Your competitive point in the nodide. These are very important, and the exam point also, out of 4, one question should ask for the 3 marks, either atomic radius, ionization enthalpy, electron gain enthalpy. Hege keltare, they may ask define particular term and how it is varies across the period or down the group enagde, and reason also you should know yake hage agtadino. This is about what? Physical trends. One more physical trends are there that are in general metallic and non-metallic character, that will discuss in the next class.